Hi everyone, welcome back to Lulumath. This video is on transformations of quadratic graphs, and this is the third of 3 videos. So make sure to check out the first 2 if you haven't already, because they will help us to have a full understanding of transformations of quadratic relations. And in this video, we're going to ask, what does the h value do in the form y equals a times the quantity x minus h squared plus k? And just a reminder, this is vertex form. And in the next video, you'll have a better understanding of why this is called vertex form, because we'll be putting everything together. So we want to use graphing technology to see what changing the h value does to the parent graph of a parabola y equals x squared. Now, since our parent graph is y equals x squared, just a quick note that it is x minus 0 squared, because x minus 0 is just x. So here we can say that the h value is equal to just 0. Now, I just want to bring your attention to something that's really important. This is x minus h squared, and this was plus k. So because this has a plus sign here in front of the k, we didn't have to worry about changing our signs. If it was positive, it went up. If it was negative, it went down. However, because this is a minus sign right here, it's going to change things around for us a little bit, and we're going to need to take a look at what's happening here in order to fully understand what's going on. So let's take a look at our first graph. Y equals the quantity x plus 3 squared, and we're going to compare it to the parent graph of y equals x squared. So if you see, we have the parent graph of y equals x squared right here, and I've typed in y equals x plus 3, the whole thing squared. And it's very important that the plus 3 is inside the brackets, because the whole entire input is getting squared, not just the x. So let's go ahead and turn it on and see what ends up happening. So our graph looks exactly the same, except now it's just shifted 3 units to the left. So if you notice here, even though this says plus 3, it's been shifted 3 units to the left. So let's talk about this. So we're going to say this shifted left by 3 units. If you notice, the general form is x minus h. So this right here is x minus some number that's going to change this into a plus 3. So the only way that I can get a minus sign to change into a positive sign is if I have a negative here. So this minus a negative turns into a plus. So here we can say that the h value is equal to negative 3. Well, now that we know that the h value is negative 3, it makes sense why it went to the left, because negative means that we're going to either go down or to the left. Another thing to notice too is that the negative 3 that we have here is with the x, and the x always tells us the horizontal direction, the left or right direction, as opposed to the k value, which tells us the up and down direction or the vertical direction right here. And the reason why we know that is because this is what y is equal to. Y is equal to something, this a times x minus h squared, plus an extra k value. So again, that k value is connected to the y, which is why the k went up and down. And if you need a refresher on that, make sure you watch the transformations of quadratic graphs number 2 video. So let's take a look and see, well, what happens if we have y equals x minus 5 quantity squared instead? So again, we have our parent graph that we have here, y equals x squared. Now when I turn on x minus 5 quantity squared, we can see that our graph has shifted 5 units to the right. So if you look and see, our vertex was originally at 0, 0, and then it's shifting 1, 2, 3, 4, 5 units to the right. And again, if you see, this is x minus 5, but because this says x minus h, this tells us that our h value is going to be equal to positive 5 in this example. So that's why it makes sense that it went to the right. Whereas again, this one was negative 3, and that's why it went to the left. So for this next example, y equals x plus 7 quantity squared, I'd like you to make a conjecture as to what will happen to this graph, and then come back and see what the answer is using Desmos and see if your conjecture is right. So again, we have the parent graph of y equals x squared, and we will turn on y equals x plus 7 quantity squared, and if you notice, it shifted 7 units to the left. If you see, it was originally at 0, 0, and then we'll count it. 1, 2, 3, 4, 5, 6, 7 units to the left. And again, in order to get this minus sign into a plus sign, that means that our h value had to have been a -7, which again solidifies our understanding of why it shifted to the left by 7 units. Now, what's your conjecture for y equals x minus 1 squared? Go ahead and make a guess. Let's check and see. So looking at our parent graph, y equals x squared, I will turn on y equals x minus 1 quantity squared. And if you notice, it shifted to the right by 1 unit, just like what we thought would have happened. I'm going to turn on all the graphs so we can see the only thing that's changing is we're just shifting to the left and to the right. And the reason why, again, is because this is x minus h, which means that the h value has to be a +1. And we can see all the graphs right here. So what's our conclusion? Well, our conclusion is going to tell us that if h is greater than 0, or if h is positive, then our graph will shift to the right. But remember, just like in our last video, we're going to say that it is a horizontal translation right. But just a quick note that h will appear to be negative. So for example, if we have y equals x minus 4 quantity squared, it goes 4 units to the right. Because the h value is +4, it appears to be a -4 because of this minus sign that we have in the actual form itself. And if h is less than 0, or if it is negative, then it's going to be a horizontal translation to the left. But again, a quick note that h will appear to be positive. So for example, if you have y equals x plus 2 squared, it will go 2 to the left because the h value is -2, even though it appears to be a +2, because this minus sign with the negative will cancel each other out to become a positive. This is one of the trickier aspects of translations with quadratic relations. So if you have any questions, please feel free to reach out. Thank you for watching. If you have any questions, let us know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be helpful, please make sure to share with others and subscribe. Thank you, and we'll catch you later. Bye.